we're just going to do solving the rational equations part today. I don't think we'll probably have the inequalities in. We'll see how much time we have. But today, solving rational equations, like I said, it goes right along with section 2 with the common denominator situation, so that you can add and subtract fractions. So we'll go through a few examples, like always. 9 over 28 plus 3 over x plus 2 equals 3 over 4. So what's different in this problem that we didn't see in section 2? What? Equals, exactly. Now we're doing equations. So if we were to cover this part up or erase this part, what would be left right there is exactly what you had in section 2. You're just adding a couple of fractions. So now we are solving equations. What does it mean, just overall solving an equation? What are you doing? Get x by itself. So you see the x right there. The goal at the end of the problem is to have that x by itself. Nothing else with it. So what you're going to do here is find a common denominator, just like we did in section 2, and you're going to multiply by it instead of get all new fractions. So this is a little bit better section because when you do that, when you multiply by the common denominator, all the fractions are gone. So most kids, once they figure that out, prefer this over section 2. So finding the common denominator. First of all, you always have to check that all of the denominators are factored and simplified, just like we had to do in section 2. Obviously, if it's just a number like 28 and 4 here, that is simplified. Nothing you can do to that. And the x plus 2 is already in factor form. There's nothing, it's not difference of squares, it's not a trinomial, there's nothing like that. It's just a factor. So that is, all of those are already simplified and ready to solve. So looking at 4 and 28, the biggest number, or smallest number that they go into would be 28. So that is part of your common denominator, 28. And that takes care of the 4 and the 28, just like we did in section 2. And what do we have left then? The x plus 2. Obviously, that also has to go into the common denominator, and that takes care of the x plus 2. So all your denominators then are accounted for. So once you've gotten that, rather than, if you remember last time, we put 3 new fractions down here and get new fractions with and change the tops accordingly. Today, though, you multiply times that denominator on both sides. This is how I write it. It shows I'm multiplying on both sides. However you want to write it is fine. Just make sure you know what you are doing. So on this first problem, it might be beneficial just to watch what I do. If you look down and write something, you'll probably miss a step. I'll give you a couple, or a minute or so after we get done with this one to copy it down, but just kind of watch the process here. So you're multiplying this times this first fraction. You do one fraction at a time. So looking at the 28 and the x plus 2, it's kind of the same as last time. What's missing in this denominator? So that's what you're going to take the top times, the x plus 2. So that would give you what? You'd have to distribute the 9. 9x plus 18. That takes care of that first fraction. Now we've gotten that one multiplied. Plus, again, same thing. What's missing here? The 28. So we got to take the top times 28. What is that? 84. And over here, this is where it kind of gets a little tricky. There's nothing here that we have here, right? We're missing pretty much everything. Here's what you have to do with the number. So 28 over 4 leaves you with 7. So what you're going to multiply this top by is 7, and then what else is missing? The x plus 2. So it's 7 and the x plus 2. Now rather than try to multiply that up there, you know you're taking the 3 times whatever it is. So you write the 3. We know we got to take it times 7, and we know we got to take it times x plus 2. Split up the steps a little bit. Don't try to do become 12 things in one step. And this is one of the easier problems. Later, you'll have a lot of things that you'll have to multiply, and you'll have to do several steps splitting that up. So once you've gotten that, this part's pretty much gone. You don't need to use that anymore. You've got your new equation down here. So can we combine anything on this side, on the left side? And that would give you what? So we got 9x plus 102. And then over there, however many steps you need to get that simplified, but 3 times 7 is what? So I would just put 21 there and distribute it. 21 times x, 21x, and 21 times 2 is what? And now, especially once you get to that point, now it's pre-algebra, algebra 1, easy equation to solve. So we need to get the x's on one side by themselves. Which one would you like to move? The 9x, how would we move that over? So we subtract the 9x from both sides. That leaves us with 102 equals the 18. Distributed the 9. 9x plus 18. Yeah, because we had it in the bottom already. So all we were missing was the x plus 2. It's 21x minus 9x. 12x. Still got the plus 42. So now what do we need to move? Subtract the 42. So we have 12x equals 60. Divide by 12. And we have x equals 5. What you do have to do, a final step on all these, is plug in your answer just into the bottoms and verify that you won't get 0 in any of those denominators. So we can't plug anything into those two. So if we plug a 5 in there, well, we get 0. So we're good. But you do have to check that every time. So x plus 5, or x equals 5 is your answer. Now, I show you that way because that's the way you'll have to do some of the homework problems. However, that problem you can solve a lot easier. And so I want to go over that way for you. We're going to do the same problem again. 9 over 28 plus 3 over x plus 2 equals 3 over 4. So looking at that problem, and again, what is our goal? What is our goal solving equations? Get x by itself. So if that's our goal, is there anything that any of you guys see that we could do? I had one student see it yesterday. Another thing we could do to solve that equation. You can't cancel anything out. Remember, we're getting x by itself. Subtract what? Exactly. So if our goal is to get this by itself, we just move the stuff over that we don't want. And this 9 over 28, is there any variable in there? Or the 3/4? You can subtract those fractions. Absolutely. And that will save you a ton of time. And most of the time, people find that to be much easier. So what's left over here on the left side? 3 over x plus 2 equals, and what do you get when you subtract those fractions? 3 over 7. Now this question nobody did know yesterday. We have two fractions set equal to each other. What do we call that? starts with a P. Proportion. And how do you solve a proportion? Cross multiply. So when you do this method, you don't even have to worry about common denominator and multiplying and stuff like that. You just cross multiply. So 3 times 7 there is 21 equals, you do have to distribute that. So you have to do 3 times x is 3x, and 3 times the 2 would be plus 6. Now that equation is very simple to solve, even compared to the other one. So 15 equals 3x. What do we get for x? 5 equals x. So you do have to know this way, because there will be problems today that's the only way to solve. But if you look at each problem and determine whether you can do this, it will save you a lot of time, and I think make it a lot easier for you. Let's flip over to the homework. Not that we're ready for homework, but just look at the problems on page 484. Looking at number 1 there, how many variables are there? Just 1. So what could you do there to number 1 instead of doing the common denominator thing? Subtract the 1/4 over. What about number 2? Yeah, you have to do the longer method. You have to get the common denominator on that one. There's no way you can subtract something over and get just a proportion. Number 3, though, I pointed this out yesterday, and a lot of people still didn't do it on their homework. So listen to this. How many fractions do you have on number 3? You have 2 fractions. You can subtract the 1 over to the other side and solve a proportion. So that second one, you have plus 2 over x, subtract 2 over x to the other side, and then you can cross multiply. Number 4, 5, 6, all of those are the longer problems. You're going to have to actually do the common denominator on those. But again, watch one. Down below, at least 10, 11. I mean, there's a few in there you can do the shorter method, so just watch for those as you go through your homework. Yep.
That one,
Which one?
the one you said.
Oh. Okay, we'll get back to it.
Couldn't you do 7 times 3 and then divide by 3 over here, except that easily? Because it works out.
Possibly, yeah. And if that works for you, go ahead. That's just it. There's several ways to get to your answer as long as you don't break a rule of math. Pretty much any method that will work. We're going to do example 2. It's on page 480. And if you look at example 2, the first thing they have there is just r, which I'm going to make x. And I would go ahead and write, if it just gives you a variable like that, go ahead and put it over 1 so everything looks uniform. Or x squared minus 5 over x squared minus 1. X squared plus x plus 2. Over x plus 1. So again, just like the last problem, you have to look at all the denominators and see if they are factored. So as your first denominator, it's a 1. Obviously, that is. What about this one? Is this factored? Is there anything you can do to that one? Right, that's difference of squares. So if you were doing this problem for homework, you could either cross that off and put x minus 1 and x plus 1 underneath it, or go through and rewrite it. Just make sure everything stays straight and in order. So we're changing that to the factored form. And is the third denominator factored? x plus 1 and then you do that? No. So that stays x plus 1. So the LCD, what's one thing that has to go in your denominator? X plus 1, that's the first one you see there. And which one does that represent? Both of them. So that takes care of this one and that one. What's left? X minus 1. Anything else left? So that's the common denominator that you're going to multiply by. Again, don't get confused and try to write new fractions because you don't want fractions. The goal is to get rid of them. So we put this whole thing in parentheses. And again, doesn't really matter how you write it, as long as you get it done correctly. If I'm going too fast, or if you got a question, please ask, because this problem will last for a while. We'll have several steps we'll be going down through. So on the first fraction, what's missing in the denominator? Everything, right? So we have to take the top times everything. So again, there's nothing. We have x plus 1, x minus 1. We don't have any of that down here. So you got to multiply that times the x. So we just write that. We have the x out front times x plus 1 and x minus 1. That's the first fraction. That's everything was missing. Everything had to multiply. So looking at the second fraction, what's missing, or what do we need to multiply by? Nothing. We have this denominator, and that's what we're multiplying by. So nothing's missing. It stays x squared minus 5. What do we have to multiply by on this one? So we know we have to take this top times x minus 1. So I would just write that out. All of that times x minus 1. And then you go through step at a time. Some of you can combine a lot of steps. Some of you couldn't combine any steps. So you have to figure out which one you are and work the problem accordingly. I know that I always say the way that I do the problems up here is the way that you should do problems. And again, that's highly stressed. Today, if you try to cram a problem like this into the little corner of a piece of paper, you're going to make mistakes. You've got to be able to see clearly all these letters, whether they're squared or cubed. You got to be able to see your plus and minus signs, or you're going to make a mistake.
Why don't we factor out x2
Factor out x squared and make it like here.
Yeah.
I don't know what they don't have that max. Plus, you don't ever factor the tops in the beginning process. But x squared minus 5, you couldn't factor that even if you did want to. Yeah. No, because 5 is not a perfect square. If it were 9, then it would be 16, but 5 is not. One thing that's highly important here, you will see this situation right here in your homework. This right here. You have to FOIL that before you distribute anything. I think in your homework there's going to be a 3 out front. You cannot distribute the 3 until you FOIL this together. Make sure you do that first. Several people distributed, you run into trouble. Do we have to do the full FOIL on here? No. What do? So I could write that right above there. If we're going to FOIL that, first x times x would be x squared, and 1 times negative 1 would be minus 1. So I changed that. FOIL it together, wrote it right above, and I just do that. It saves a step. Instead of writing out the whole next step, you can kind of cut steps down a little bit. So now we can distribute the x in there. So x times x squared is x to the third and x times negative 1 minus x. So we've taken all that, now we're down to there. Can't do anything, plus x squared minus 5, that's already put together. So are there any like terms over here on the left? No. Cubed, x to the first, x squared, and a constant. You can't combine that at all. Over here, on the right side, we have a trinomial times a binomial. So what do we do there? Do you FOIL that? No. So what you've got to do here, and we've done it many times before, is take the x times all three terms and then the negative 1 times all three. So how many terms will you have? 6. You have 6 numbers listed out there. Write them neatly and carefully. So x times x squared, x to the third, x times x plus x squared, and x times 2 plus 2x. And then you do the same thing with negative 1. Try to make this close. So negative 1 times x squared minus x squared, negative 1 times x minus x, negative 1 times 2 minus 2. Remember, what's the goal? Get x by itself. Looks pretty challenging. There's about 5, 9, 10 x's in there, something like that. And you got to get it down to 1. We've already said this side is simplified. We can't combine any of that, but we can on the other side. So we go through and we add and subtract like terms. Do we have any other x cubed? So that goes down here. X squared. Yeah, we have 1x squared minus x squared, so that cancels out. And then we have 2x minus x, that would be plus x. And we still have the minus 2, so everything's combined there. So what's going to happen when we start moving things around down here? What's the first thing that's going to happen? X cubes are going to cancel. If you subtract this one over, it's going to cancel. X cubed minus x cubed. What? Right, so if we move this x over, basically we've got to get this right-hand side to be 0. So we've got to move all of that to the left-hand side. So if you move the x over, minus x and minus x, what would you get here for the minus x? Negative 2. Yeah, negative 1x minus 1x is negative 2x. And a lot of you could have added the 2 over in that same step. I'm just splitting it up for those that couldn't do that. So how do we move the 2 over? Add it, final thing. So we got negative 2x plus x squared plus minus equals 0. Is that in the right order? What do we need to do? We need to bring this x squared to the front. Just rearrange it. Minus 2x minus 3 equals 0. How do we get our answers from that? Quad 3, go for it.
X minus 3 plus 2.
X minus 3. Now, I'll go ahead and write that down. X plus 1 and x minus 3. So we have to find the zeros. So x equals negative 1 and x equals 3. So can we save ourselves that step? Your calculator will tell you the zeros. So rather than writing the factors down here and then solving them, your calculator in quad 3 will give you those right out of your calculator. So what are the zeros? We just had them, negative 1 and 3. So rather than write those factors, just write x equals negative 1 and 3. Those are your two answers. What did we have to check on the last one at the end? Right, so we got to slide back up there to the top and plug in negative 1 and 3 in the original. Here are your denominators that you got to plug into. So if we plug 3 in here and we got 3 squared, that is 9 minus 1 is 8. Over here, 3 plus 1 is 4. So 3 definitely works. But if you put negative 1 in right here, what do you get? 0. So negative 1 does not work. You just cross that one off. 3 is your only answer. Yeah, I don't know what you're asking.
X2 and X3 equals positive.
Here?
Yeah. Or X is and then divide it, and then
I'm not seeing.
okay, so now instead of doing that, add 2x.
To the other side? And then do what? No, I don't think I could do that. Okay, just to humor you, you have x squared minus 3 equals 2x. And what did you do?
I divided by 2.
And that wouldn't do anything for you, except now you have x equals that. I would just go along here. 7x over 3x plus 3. Minus 5 over 4x minus 4. Equals 3x over 2x plus 2. So, starting fresh. Another example. We're doing all the same steps that we did in the last one. So we check first what? Factor all the denominators if they're not. Can we do anything to this one? 3x plus 3. Take a 3 out. So I would just rewrite the problem and factor those bottoms. We take a 3 out, we are left with x plus 1. Minus, can we do anything to that denominator? Take a 4 out front, divide that out, we have x minus 1. And on the last one, what? Take a 2 out, and we have x plus 1. So those are the 3 factor denominators. Now you get your common. So we have numbers out front, 3, 4, and 2. What's the smallest number they go into? 12. So I'm going to write it up here. We know we got a 12. That takes care of the 3, 4, and 2. That's represented by the 12. What else do we have? Okay, we got an x plus 1 here. And that represents, it doesn't matter if you cross these off or not, but that represents both of these. And we've also represented all those numbers. What's left? X minus 1 has to be in there. So that's what we're multiplying. Everything times that. So here's what we're multiplying. Here's what we have. What's missing in the first denominator? So the first thing that's missing And here's how I would do this. We know we're going to multiply whatever's missing times 7x. So I would write that down. And we need a 12, we only have a 3, so what do we have to multiply by? A 4, that's got to go multiplied. And which one of the other two factors is missing? The x minus 1. So I would just write out everything that's you're multiplying. What you do have to be careful of is this minus in the middle, because that will change all the signs past it. So we have a 4, and we need a 12, so what do we have to multiply? And since that's a minus, you need a big parenthesis right out there, so you know that minus has to be distributed later. We definitely have the 5. That's what we're multiplying by. And we've got to take the 4 times what to get 12? 3. And which one of the other factors is missing? The x plus 1. And close all of that. All of that's inside there, and the negative has to go into it. Equals, over here, we're going to multiply the 3x, that's the top, times whatever's missing. So we've got a 2, we need a 6, or we need a 12, so we have to take it times 6. Which one of the other factors is missing? The x minus 1, we've got to multiply that as well. Now, some of you could have done some of these steps as you went along. For instance, I know you could have done 7x times 4 is 28. You probably could have distributed the same step. So go ahead, do as much of it as you can in one step. Just don't do too much. So what is 7x times 4? 28x. So we got 28x there, and we're going to distribute it. 28x times x, 28x squared, and 28x times negative 1, minus 28x. I keep that big minus right there and do the same thing to that one. 5 times 3 is 15, and then we're going to distribute that in. 15x plus 15. Do the same thing one more time. 3x times 6 is 18x, and we're going to distribute that in. And that is 18x squared and 18x times negative 1 minus 18x. So what do we still need to do on this left-hand side? Right, that's what I would do first. I would leave this all 28x squared minus 28x, and then distribute that negative in. So it's minus 15x minus 15. And as I said, I know there's a lot of steps. Go slow. We won't have a ton of homework problems, so you'll have time. Don't make mistakes. So we've got 18x squared minus 18x over here. We've got to get rid of both of those. We've got to get that side to equal 0. First, though, can we combine anything on the left? These two x's in the middle we can combine. So negative 28x minus 15x is what? So minus 43x minus 15. We can't combine anything there. So how will we move that negative, or that 18x squared over? Subtract it. And this time I am going to combine. How would we move the 18x over? Add it. And we can do that in the same step. So now this is all gone. 28x squared minus 18x squared. It's 10x squared. Negative 43x plus 18x. Negative 25x minus 15 equals 0, and that's ready for quad 3. What can you take out of there? A 5. Quad 3 will do that for you as well. So remember, we don't care about factors. We want zeros. So your calculator, once you plug that into quad 3, tells you x equals 3 and negative 1/2. We plug 3 into the original up here. Is that going to give us 0 anywhere? It is not. What about negative 1/2? That's going to be negative 3/2. That's not. What's half of 4? And that's going to give you, not going to give you 0. What's half of 2? And that won't give you 0 either. So both of them work for that example. So look over at your homework. We're going to do 1 through 6 there at the top. On page 484.